Hello and welcome to our new course DSA Pro. This is an add-on course to our Propel program, and in this course we will learn data structures and algorithms in an interview perspective. This course will help you to crack interviews, and also we will see why in this AI age where AI can generate code, what is the significance of learning data structures and algorithms. Let's see. Understanding data structures and algorithms are essential concepts in computer science, which enables data management, problem solving, finding the most efficient way to solve problems in computer science and also in computer programming. And let's now see why learning data structures and algorithms is very important in our current scenario. It's not only about interview preparation, it describes how data is stored or how problems can be solved optimally with less compute cycles and how systems can scale efficiently. Just like I said here, it's not about the syntax, it's about how you think and how you implement your thinking in programming language. It could be any programming language. We will be focusing primarily in Python here because it's a beginner-friendly programming language, and in your previous camps you would have already learned Python. So it will be better if we proceed with Python. And why it's very important for freshers and students to learn data structures and algorithms, because it builds logical and analytical thinking capability. You use coding as a tool to solve the problems. It will increase your confidence in tackling new problems, because a big problem will be or will always be a group of small problems. So if you learn how to solve these small problems, it can help you solving bigger problems, and it will make learning new technologies easier, because mathematics or problem solving is the main thing that is behind all the technologies. And the product-based companies, even the bigger ones like Google, Facebook, Microsoft, all these companies will expect their employees to be familiar with this DSA essentials. And like I said before, it's not about the language or framework. It always change. The frameworks which was there 2 years back is not there right now. Or maybe a new framework has emerged or new programming languages emerged. But the way, the logic that you use to solve problems will always remain the same. And DSA is widely used in real-world applications, like in search engines. They will be using the DSA concept of trees, graphs. In social media also they will be using graph. Navigation apps use graphs and shortest path to get you to your destination using the shortest path available. Then operating systems always use this data structures like stack, queues, heaps. They will be using it to manage memory and to manage the process, the priority of the process. Then databases will be using trees and hashing to search through the database. Let's see how our course is organized. We will start with a very structured curriculum. At first, arrays, which the most simplest fundamental data structure. We can access the elements using index, and it's a base for other data structures. Then we proceed with strings, which is built on top of this arrays, a group of characters. We can manipulate, we can go through those characters. Then we have linked list, which is an interesting data structure which uses dynamic memory allocation. The insertions, deletions, etc. is very efficient compared to other data structures. Then we have stack and queue. They are called as linear data structures which follow strict rules in insertion, deletion, etc. Then recursion and backtracking, in which we will learn how to solve a problem by breaking down that problem into sub-problems, which will improve the logical depth of the problem. Then comes the trees and binary search trees. Trees, just like in real world, have a root and its branches. Similarly, we have the hierarchical data representation for fast searching and sorting. Then heaps and hashing. In heap, we will be having priority-based processing, scheduling, and optimization. Then finally, graphs, which is also similar to tree, which represents real-world connections, just like the computer networks. Then we will also learn some optimization in our dynamic programming section. We will learn how to do the problem solving without repeated computations and using less computational resource. We will see how we can optimize things. That's our plan. We'll be starting with arrays in our next session.